Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so this is, these are 3 lines and it doesn't work. If I try to rotate this, can I rotate it? Can I do it? Can I do it? Maybe, maybe not. But you can see that these will not connect. If I rotate this in, it's not going to be long enough to connect to that blue line, okay? So if you have 3 lines, here's what you could say, here's what I would say in English, that these 2 lines, if I put these together, they wouldn't meet and connect to this red line, all right? So the blue and green have to be able to, when you add them together, have to be more than the red line, okay? So basically, if for the 3 sides of a triangle to form a triangle, the 2 lesser sides have to add up to greater than the biggest side, okay? Now this is how they word it right here, 39.4. This is called the triangle inequality theorem. The sum of the lengths of any 2 sides of a triangle must be greater than the third, okay? So for example, if this was, let's see, this looks like maybe 2 units, and this looks like 1 unit, and this looks like 10 units. So see how 1 plus 2 is not greater than 10. Now 2 plus 10 is greater than 1, and 10 plus 1 is greater than 2, but it has to be true for every combination. So basically, the easiest way to tell is if you look at the 2 smaller sides and see if it adds up to more than the third side. Okay, so look at this example. A triangle could not have the side lengths of 3, 5, and 9 because the sum of 3 and 5 is less than 9. So if I tried to draw this triangle, so let's say this is 3, or this is 9. So 5 is about a little bit less than that. So let's say 5 is about right there. And 3 is about right there. So see how they won't connect. The 2 smaller sides are too short to be able to form a triangle. Okay, this is something that I never really thought about until I started teaching. I think, I don't remember this, learning this in geometry, but when I started teaching geometry again, I was like, oh, wow, I don't think I ever realized that. I thought you could just make triangles out of anything. But maybe I realized it, but I didn't know it was a general rule. Well, it is. The 2 smaller sides have to add up to more than the big side, okay? All right, see if these are triangles. Well, we already know a 3, 4, 5 is a triangle, right? That's a right triangle. And if you look at the 2 smaller sides, 3 plus 4 is greater than 5. So yes, it's a triangle. Okay, what about 5, 11, and 6? Is that a triangle? Okay, look at this. If I tried to add, well, first of all, the theorem says 5 plus 6 has to be greater than 11. It can't be equal to 11 because look, if it was equal to 11, it would look like this, or backwards, I guess. Right? So that's just a flat line segment. It's not a triangle. So 5 plus 6 have to be greater than 11. So 5 plus 6 is not greater than 11. So no, this is not a triangle. What about 1, 9, and 5? Well, take the 2 smaller sides, 1 and 5, and see if it adds up to greater than 9. Nope, it doesn't. So this is not a triangle either. Okay. So can you guys handle that? Can you guys determine whether a triangle is a triangle by looking at the 2 smaller sides, adding them up, and making sure that they're not, that it's greater than the last side? Okay, good. So that's just the solution to that. All right, so here's the trick. Now you have to find the range of values of x. So remember, x has to be 4 plus, so let's see, the longest side is 7. So x plus 4 has to be greater than 7. So if I write an equation here, x plus 4 is greater than 7, then I can solve for x. Subtract 4, subtract 4. So x has to be greater than 3 for this to be true, okay? Because 4 plus x have to be greater than 7. Well, what do you add to 4 to get greater than 7? Anything greater than 3. 3 doesn't work. Remember, 4 plus 3 equals 7, so it can't be 3. It has to be bigger than 3. Does that make sense? So you can solve that algebraically. Are you guys dancing in the back?
Oh, sorry, I was swaying because I don't know, I've been doing that a lot recently.
No, that's okay. Whatever helps you concentrate, you know? It's just making me dizzy.
Oh, sorry.
All right, good job. All right, so does this make sense, guys? Can you figure out what x has to be for this to be a triangle? You just remember the two smaller sides have to be add up to greater than 7. So whatever x makes this sum greater than 7. Good?
Yes.
All right, moving on to lesson 40. Good job, guys. Okay, so we're going to talk about perimeters and areas of composite figures. Well, what the heck are composite figures? Can you guys figure that out? Well, composite, do you guys know what composite wood is?
Fake wood?
Do you guys know?
It is?
That?
Fake or filler wood?
Filler? Like,
Yeah,
like,
so it's
okay.
different kinds of wood that make like a plywood sheet or whatever, but it's not plywood. It's actually composite wood. So it's these different types of wood are together. You guys know what a mutt is? Like a dog, a mutt?
Yeah.
Do you guys know that mutts live longer than purebreds? You guys know that? Because they are a combination of different dogs, and so they last longer. That's my theory anyway. But it makes it stronger when you have different things together. So here's my whole point. I'm not talking about dogs, and I don't know if I'm not a scientist, so I don't know. You can ask my brother if mutts last longer than purebreds. But areas of composite figures. Composite figures are just different figures stuck together. So composite figure is something like this. You guys remember finding the area of things like this? Okay, so you can find the area of the rectangle and then find the area of the triangle and add them together. So that's just 40 plus 12, which is 52 square units. Do you guys remember doing that in pre-algebra?
Yes.
yes.
All right, and you can do the same thing with perimeter. If there was a perimeter here, let's see here. You can still find the perimeter, 8 plus 5 plus 4 plus 4 plus 5. You just go all the way around. Same thing. That's what we're doing today, but we're going to go a little deeper than we did in pre-algebra. Okay, so a composite figure is a plane figure made up of simple shapes, or three-dimensional figure made up of simple three-dimensional figures, okay? The perimeter of a plane of a composite is the sum of the lengths of its sides, okay? So you're not when you find the perimeter, you don't include this, all right? That's not important. It'll be important when you're finding the area, composite area, but the perimeter, you just walk around the building, okay? So same thing what we did in pre-algebra, just add them all up. Now, here's postulate 19. The area congruence postulate says, if two polygons are congruent, then they have the same area. Well, that's duh. So if I just have a triangle, it's not going to let me copy. Can you let me copy and paste it? Didn't let me copy and paste it. Oh, well. So if you have this two things, then they have the same area. That kind of makes sense, right? It's almost embarrassing to even tell you this postulate. If two polygons are the same size and shape, or that's what it means to be congruent, then they have the same area. Well, duh. Okay. Now, here's postulate 20, area addition postulate. The area of a region is equal to the sum of the areas of its non-overlapping parts. Okay? So you can't overlap anything. You can't find the area of this thing and then this triangle that or this trapezoid here. No, just find the area of the triangle, and this rectangle, and then add them up. They can't overlap. You can't add the same part, same area twice. Okay. So this is, again, this is review. This is just written down in a way that's new to you. So write these down. Postulate 19, area congruence postulate, duh. Postulate 20, area addition postulate. So to find the area of a composite figure, you have to find the area of its non-overlapping parts. Okay. Okay. So that just leads us to these pre-algebra problems. You can find the area of this, right? So look, it kind of gives you a hint that, all right, these two triangles are the same because of the SSS postulate. Remember the SSS postulate says if all three sides are congruent to all three sides of another triangle, then the triangles are congruent. So if these are congruent, then the area of this is going to be the area of this. Can you calculate the area of this triangle? One half base times height, right? What is that? 17 square inches. And it's also 17 over here, right? Boom, boom. Good. And then the area of this, what's 6 times 8.5? You guys know? 51. So the total area is going to be 51, which is that rectangle, plus the two 17s. 51 plus 34 is 85 square inches. You guys remember doing that in pre-algebra? Okay, the only thing different here is you can't just assume this is the same triangle. Well, it is the same, it's congruent because the three sides are congruent. How do you know these are congruent? Because these are opposite sides of a rectangle, which are congruent sides. So SSS, SSS. All right. So if you are finding the area of the subtract, you can find the area by subtracting. So this, I call this the carpet layer method. So a carpet layer would not make two pieces of carpet. All right. Carpet layers hate seams. Even if it's a little bit more wasteful, most carpet layers will lay down the whole carpet and then cut out what they don't want. So in math language, that's just a subtraction problem. So the area equals the big rectangle minus what you don't want, minus that triangle. Okay, so find the area of that big rectangle. 26 times 10 is 260, plus half of that, 130. So that's 390 minus the area of that, 11 times 12 is 132. So that's 258, I think. My cheat, here it is, 258. Okay, so does that make sense? You don't have to, so, and you can't really determine that. Well, I guess you could determine that value there. So if that's 12 from here to here, and that's 15, so that's 3. So you could find the area of this trapezoid here. You can find the area of this trapezoid, and then you'd probably have to box it off like that. You could do it this way if you wanted to. You could even break it up into these parts here. And let's see, that's a 3 by, well, what's that measurement? Well, that's 20, so that has to be 4 there. So let's see, this is a 4 by 12, so that's 48 there. And then this is like a, oh my goodness, this is a pain in the butt, isn't it? 22. So you could do it that way if you wanted to. What is that? 22 times 26. You can add them all up and you'll still get 258, but see how it's much easier to use the subtraction or the carpet layer method. Okay? Can you guys handle a subtraction problem like that? Thumbs up, thumbs down. Subtraction should scare you because subtraction is dumb. So try to avoid subtraction at all costs. All right, here's like the same kind of thing, architecture. You could look at those real life examples, but we don't really care about real life and geometry. So I think that's it. So here's what I would suggest before you leave today. You've got almost a half an hour. I would start working on some of this homework. Let's see, maybe I can email it to, let's see, what is that? 40. So I can email this PDF so you can start working on it. And then maybe Mrs. Powell can project it on the TV. So maybe I'll email it to Mrs. Powell. But I don't think Mrs. Powell, do you have an email address with Jeffco still?
Yes.
Okay, so I'll email you the PDF to these assignments, and you just have to scroll down till you see it.
Okay.
And then they can work on it if they want to. If they have other homework, they can work on that too. But and you guys, if you most of you have turned in your test, and if you haven't turned in your test, you need to do that as soon as you can. It's already late, so turn it in as soon as you can. We can do test corrections too. Do a Zoom call with me. I'll give you half credit back, up to 15 points back. Okay, so if you get a 70 on your test, you can raise it to an 85. Okay, if you do it without a Zoom call, you can still just do normal test corrections. I'll give you up to 10 points back. So if you got a 70, you only get an 80. So I want to bribe you with Zooming with me because I'm pretty confident I can explain something to you in a way that will make you understand. Okay, so schedule a Zoom call with me and we can do test corrections together. Okay, any questions? All right, I'm gonna email that. Oh, is there a question?
Any questions? Any questions? Any questions?
Okay.
Any questions?
Good. All right, good job, guys. Good to see you. We'll see you on Thursday. Hey, Kate, do you have a question or are you just waving?
Waving.
Oh, you're so nice.
Oh yeah.
Thank
Thank you very much.
Yeah, thank you guys. Good to see you. We'll see you Thursday.
Black man, give me some math and I'll give you some flack. Black man.